Okay, so do these two statements make sense to everybody? Do you understand where those are coming from? Yes? Okay. And the game is that we're trying to put these things together to get a relationship between what two values. Do you remember? Last time? What were the dependent and independent variables from our lab? Mass 2 was the dependent variable, and then and time was the actual independent. That we can. So I'm going to put forget. These are the two things that we really want to isolate. So FG2 is the mass times acceleration. What is F1 on 2? Do I know that value? I do sort of. Tell me more about what you mean.
Well, you know that it's the mass of, it's the mass of F1 times the acceleration of F of the object 1.
Okay, so together. F2 on 1 and F1 on 2.
They are
is really the mass times acceleration. And okay, this is 1. Here's 2. So the force of 2 on 1. Here's the force of 1 on 2. Here's the force on 2. So negative. Negative. Is F2 on 1 positive or negative? I'm going to write M1A, okay? Because these guys are the same, so I'm going to write that down. And then I'm going to write this one positive. Down. Oops. I'm going to include that negative. Is that statement okay? Okay. We know M1. We know G. M2 is the we're measuring, and A is one of the things that we were measuring. Were we really measuring? No, but we can find it, right? And we know from last time when we were doing the derivations of the equation that there is actually an equation that would be convenient that might relate time, which is what we measured, and the displacement that we measured, didn't we? And the acceleration that's hanging after. Oh, yeah. Would you take a look at your equations that we just had last time? And if you don't have that because you weren't here, then talk to somebody. You can figure out how to. Did you find it? Did you find a good choice? An equation that has these things, and maybe has one more thing in it that we also know what the equation is? What equation are those two things? Sure. We derived it. We found it, didn't we? What was the equation? Change an x, so I'm just going to call it b. Is that okay? Is equal to? Uh-huh. Is that okay? Yeah? Okay. Zero, so that's nice. So you've got d, excuse me, is equal to 1/2 at squared. Could you solve that for a for me, please? Why, yes, Miss Carberry, I can. Once you've manipulated that equation, check with your neighbors and see if they agree. Displacement is a vector. Yeah. Yeah, I just got lazy, sorry. All right. What'd you get for A? Raise your hand. Somebody I haven't talked to you today. You guys should have all done this, didn't you? Or no? Were you able to do that? Were you able to get A all by itself? Yeah, raise your hand and tell me what you got then. Somebody, please. David, go. I don't know. Is it? Two times D? Is that okay? Okay. Now, I paused this a little bit early just because I got really excited about the acceleration thing. I'm going to make a suggestion here, and let's combine our A's together. Does that sound okay? Can we put our A's together? Actually, not even combined. I want you to take this equation right here. This is just a little algebra, like warm up for your brain this afternoon. I want you to solve this equation for A. Then we'll have two equations that both have A in them, and we can set them equal to each other. Got it? Do it. Talk to your table mates. Help each other out. Algebraic manipulation for your Tuesday afternoon. What more could you ask for? I mean, really. What's that? I don't care. I just want you to do it. So if you want to talk through it with your group, that's fabulous. If you don't want to, that's you can. How's it going, team? Find this. I got this A. We got this thing. Like, yay! Why are we doing fun? What's the whole point of this? We're trying to get some sort of relationship between T, yeah, between M and T. That's our goal. Okay? We figure it out. So what I want you to do right now is to plug these together. and then let's some algebra together. So we've got he's like, wow, Miss Cartling, that's pretty, right?
Well, we can always cross multiply.
Right. So the game is, let me remind us kind of what we're trying to do, because that's what I. We want to get something that looks like that. Okay. Does this right now look like this?
Not really.
Trevor's like, I'm done. Like, whatever. Okay. So the suggestion is multiply with root, right? Then the denominators, that's a helpful thing. Let's press multiply to it. You know what that means, right? Da-da-da-da-da.
Actually, it means you can also.
So m2g t squared is equal to 2d times m1 plus m2. Like we're making progress at least, huh? It kind of, yeah. It's not exactly because, but we got the t squared on this side, right?
AP1.
Let's do it. So what do you want? So again? Okay. Okay. So you want to? Okay. So give me instruction. I like it. Just figure that in. Okay. No, it's all good. It's all good. That's what I didn't want to assume. Is sometimes that's dangerous. Okay. So you're gonna move this one over here. Okay. 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 Now the only little bit of a hang up that I have about that is that just I'm trying to make sure that I have the two things that I want to graph, the two things that I measure, time and which math. M2. I want those on opposite sides of the opposite sides of the, and the thing you just suggested we put them on the same side. No, I'm totally with you. Did you understand what she said? Yeah. So we have both of them over here now, right? Yes. Oh, that all in her head. That was awesome. I'm like, I have to write it all down. I want you to do that because I want to see if it's equal to the thing that I have. Okay? You do that. This is what I'm going to suggest. Not that one is better than the other. This is what my brain looked at. And again, the beauty of this stuff is there's not one right answer. It's cool. All you want is to have one thing on one side, one thing in one place.
Oh, that gets messy with the two.
No, I'm going to divide by m2 times c. That's what I'm going to do. If you want to do it that way, I don't care. So I'm going to divide by m2 times e. M2 times G, M2 times G. Is that okay with everybody?
Wouldn't the 2dm1 plus 2dm2 all be over the same m2g?
Yeah, but I don't want it to be. Let me show you why.
Oh, and you can.
You want me to show you why? Does that make sense? So these guys are going to go away. So I've got p squared on this side.
P squared.
This thing is disgusting.
Yes. Going to cancel.
I'm going to have a big, huge mess of stuff. 2dm1 over m2g plus 2d over g. And now I'm going to say, what do you think?
Yeah.
Grosser?
Maybe if we did spread it like size. Did the spread it
So,
like size, we find it
this was a while, right? There's a little analysis but if we graph something clever, we can get a straight line. What are we going to put on the y-axis?
times squared.
Times squared. What are we going to put on the x-axis? Keeping it as simple as possible. Oh, you're crazy.
As far as
I just want stuff that I've measured. What if I do this?
or without.
Does that help at all? What should I put on the x-axis? 1 over m2. 1 over m2. And what kind of a shape should I get? A straight line. A straight line, hopefully, with a slope of what? 2dm1 over g. And with a y-intercept of what? Yeah. Isn't that kind of cool? That makes sense. Now we're going to cross our fingers. And we're going to plug some stuff into Excel. Right? It might be hard to type things in with your fingers crossed. So I recommend. But what I want you to do right now, raise your hand for me if you've used Excel before. Raise your hand if you feel confident doing formulas in Excel. Okay, cool. I am going to get you confident by the end of the class today. I've got an hour. No problem. I've got it. I have full confidence that I can do it. It will require that you pay attention, that you stay with me, and that you follow along, okay? But I believe that I can do it. I believe you can do it. All right. I'm going to open up an Excel spreadsheet, just like you. All right. The first thing that you need to know, or the first thing you do is to put the data in. So Excel is this really awesome program. Everything as long as no reason for you to calculate unless you're I want you to do right now. I'm going to just you don't have to label them exactly like I do, but I label them something that will be helpful. Like I'm going to say raw data here so that I know that this stuff is just my basic data. That's not the stuff that I'm going to graph, okay? What did you measure in your lab?
The number of plates.
Yeah, you measured time. You measured, what else? Take a look at your data. If you don't remember, it's been a few days. You did mass, right? I call it mass 2 just so I don't get confused. And be a good kid, I'm going to go ahead and put the units in. What units do you think we probably want our masses in? Kilograms. If there's anything that I do here that doesn't make sense, let me know. Or if there's something that you're having a hard time seeing or whatever, let me know. I do want to tell you right now that if let me say this real quick, River, and then I'll answer your question. Ask all kinds of questions. Don't answer. I'm going to put my little cursor up in between A and B, and it's not quite big enough. I double click, and it expands automatically to be the right size. Yes. So if my row, here, let me turn this light. Like this column is not wide enough so I can see everything that I typed in there. If I take my cursor and I take it up in between A and B, and it turns into that little like arrow thing, I double click, and it will make it the correct width so that it fits everything. Just one of those little Excel tools. And then for time, I'm also going to put my units. What are my units for time? Seconds. Oops, not capital S. All right. I'm going to give you just a moment to plug in your data. So you've got one, like, Jonathan, what was your first mass that you used?
1 weight.
Okay, what was the mass of it? Okay, I'm going to put in that mass, and then I'm going to write down how many trials did you do?
We did 3 trials per number.
Okay, so I want you to put in those 3 times. So let's say it was I'm just making up numbers, 2.3 and 2.6 and 1.9. I want you to put those in for each of your masses and then your trials. Does that make sense? That's all I want you to do. I'm going to give you a couple minutes to do that, and I'm going to come around and answer questions. Okay? Go.
First weight 007.
Can we use grams or let's convert to kilograms?
I would recommend converting to kilograms now because everything eventually needs to be in kilograms. Otherwise, your data is going to be all. So let's just get it fixed now. Now, River, if you want to be really, really lazy, he's like, yes, I do. I'm going to show River something, and he might all want to see this if you want to be really lazy. So let's say that River doesn't actually want to do the conversion in his head by moving the decimal over 3 points because, that's a lot to ask, right? Okay, so let's say that you had, can you tell me what your mass was? 15.77. So you could have over here, let me show you what I'm doing. I'm going to move all this stuff. So these are just little things that you can do in Excel just so you know. You can highlight cells and then you can just drag them over and then, they just move. So let's say that we did mass 2 in grams. So we had 15.77. And again, I'm exceedingly lazy. So instead of having to do that, I'm going to type in equals. I'm going to click on that cell. And I'm going to divide by 1,000. Boom. Okay, now, so tell me the next two masses that you had. 22.87. 77. Okay, now, to be fair, we would need to move these down 10 more times, but this is cool. Once you have that there and you've typed this in to be exceedingly lazy, then you can just go like that, and now you're just exceedingly lazy all the time. Okay? You're going to love Excel because it does everything for you. Honestly, all you have to do is have your raw data and know what you want to do. You know what I mean? It'll do everything else.
Can I ask questions to the Mac users?
You may not be, yes, of course. Like,
How do we do this on the Mac?
well, how do you do what?
What you just did on the Mac.
It's the same.
No, but
what do you want to know?
Because Excel.
You don't have Excel, or you don't? You have to use Excel. Because if you don't have Excel, then you have numbers and that. What do you want to know? Oh gosh, then go get a computer. Numbers is terrible. Numbers is terrible. Excel is good. Go get one on my computer. Numbers is evil.
Why is numbers evil then?
Because it doesn't do what it do. Numbers.
See that right button down there?
Okay, have we got all of our data in?
Not quite.
Okay, get some more data in. I typed in equals, and then I clicked on the box, and then I said divided by 1,000. Okay.
But I know how you do averages.
I'm gonna get all of us there in just a sec. Okay. Three masses. Give me the time. Yeah. Okay. 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 Keep going. A different mass? That's what I thought. Okay. 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 All right. So I've got some data. Is it okay if I move on? Yes, no? Do you need another 30 seconds to get done? Where are you at? You guys okay back there? Raise your hand if you need a couple more minutes to get, or a couple more seconds to get data in. Okay, I'll give you another minute. Go ahead. More or less, at least for now. Okay. What do you mean broken? Okay? I'm going to pause you for just a minute. If you're not quite done, that's okay. But I want you to look up here for just a moment because I want to show you how to do an average. So I want to find an average of these three numbers. Okay, so I'm just going to make another one over here. I'm going to say this is time, or I'm going to say average time in seconds. And I'm going to make it big because I can. Ha, there it is. All right. And then either in the box there, you can double click to get there, or up here in the function. Either way is fine. So listen to, even if you're not quite done typing in data, listen right now so you can see what to do, so I don't have to repeat it over and over. I'm going to hit equals, and then capital AVERAGE. We know that word, right? Okay. Then open parentheses. So all of the things that you're going to have to do is going to calculate things for you. You always will have an equal sign. Saying, I want you to do something. Okay? If it's going to do a function that knows, like how to take an average, then it's always going to be in big caps. And if you're not sure which one, you can always go to help or just type it in, and usually you'll get closer. They'll help you. Open parenthesis, and then you're just going to highlight those three cells. Those are the three cells that I want to take the average of, please. Close parenthesis, enter. Done. Okay. Now, because of the way I set this up, we can't really drag down because it won't work super well. So I'm just going to come back down here. I'm going to do the same thing, or I'm going to copy this, Control C, and I'm going to, oops, undo. Equals average, boom. This one here, it means that it's a calculated cell. So it just basically means that it's not a number that you typed in, but it's a number that it's figuring out for you. Okay? The thing that's nice about that is that let's say that you typed one of these in wrong. Maybe this was supposed to be 3.27. When I do that, my average changes. Like that. I don't have to think anymore. You okay? What's that? It is on the map. Whoa! It hasn't been ruined by the fact that it's on the map. You're okay? Yeah. You're averaging. Everything okay? Wait. I know, it's a good thing.
Aside from trying to make if-then statements using Microsoft.
Now, we want to remind ourselves, I don't remember, I have it in front of me. What were the things that we wanted to graph on our graph?
T squared versus 1 over 2.
Is that okay?
Yes.
So we're almost there. We need to get two columns, one of which has t squared and one of which has 1 over m2.
Mm-hmm.
Is that doable?
Oh, yeah.
Oh, yeah, no problem. All right, so let's do it. I'm going to make another, I think, let me see here. I'm just trying to make this a little bit nicer and prettier. I'm going to copy these cells. And I'm going to paste them over here just so that I can take my space out. Oops, I'm going to move these up. It's just an aesthetically pleasing thing for me. I just like it. Oops, except I don't want those ones. River, why did you tell me the ones in grams? That was silly. Nothing. Actually, okay, never mind. I don't need to be aesthetically pleasing. Okay. I want to do 1 over M2. I'm just going to write that as 1 over M2. Is that okay? Okay. Here I'm going to write equals 1 over mass 2. Boom. And then in this cell, do you see the little spot where it has a little square at the bottom? I'm going to grab it and drag it down. And this is, oh no, you're dividing by 0. Go away. We don't care. I did equals 1 divided by, and then I just clicked on that cell. And then what is the other one going to be? P squared? I'm going to type in equals time caret 2. Drag down. And again, I'm just going to get rid of these zeros. Do you want me to say all that again? Yep. Yes, please. All right. So backing up, I went back to what I was trying to do, what I was trying to graph. We said that we wanted t squared on the y-axis and 1 over m2 on the x-axis. So I just need to make 2 columns that know those things. So I've got 1 over m2. That's the label, so I don't forget what's going on. And I'm going to click in this cell, and I typed in equals because I wanted to calculate, right? Calculate 1 over 1 divided by, and then I clicked on B3, which was the mass in kilograms. Okay. Yeah. You type in equal. Okay, so do you have this stuff? Or you will? When you want to get the columns in the just below that we have your one, that was equal 1, the number divided by, okay, that stuff. If you go up to the label space and double click on like in between them. Does that make sense? Do we say that again? Yeah, so you just put your cursor or your, yeah. Nope, just double click. How are we doing, Chris? For this one, yeah, we don't want to do like what we want to do. We want to literally do the time. That's okay. That's what I want. Because I don't care about the these ones. The whole purpose of that was to and then if you just drive on that floor down. Yeah, let me look at go up. Are you sure? Okay. As long as you know what you're doing. All right. Do you need one more moment?
Yes.
Okay. You don't count because it's going to take you a little while. Anybody else need a moment still? Okay. What's that?
Is there a way to format this to do it to entire columns at once? If you're only working with individual boxes?
I don't understand what your question is, Jonathan.
Like, let's say, like if you had for some reason filled in the empty boxes in the mass 2 kilograms column with those same values, could you have done the 1 over M2 thing for the entire column in one stroke? That seems interesting.
Why don't you plug in the other values that we're going to need? Can somebody remind me what other values you measured that we may need to use to calculate our slope?
Distance.
The distance? What else?
And mass 1.
And mass 1. And is there anything else on that equation in that y equals mx plus b form that we would also need to include? Gravitational acceleration. I'm going to go ahead and just list those someplace so that I can do my calculations really easily. So I'm just going to type over here in another column, constants. Then I'm just going to go ahead and type them in. So I'm going to say distance in meters. And then go ahead and the way that it works in my head is just to put them the mass M1. Make sure that's in kilograms as well. And the acceleration due to gravity is in meters per second squared. I know that that's 9.81 or 9. We're using 9.8, right? $493. Okay, so 0.493. I'll be there in a second. Learning is good. I don't know who that was, but learning is good. Okay. All right. Yeah. I hope so. I asked you to, so I hope that you did. So before I do my graph, just so that I kind of know how I do, is that okay? And they're warning on everybody else as I just like everybody. I'm going to calculate my slope. The slope I should get if my data was good. Okay? So I'm going to go over to this thing next to expected slope, and you can have this wherever you want on your data on your Excel spreadsheet. I just wanted it there just so you could see everything. This right here is my slope. Okay, this thing here in my equation, are you okay with that? So I'm going to type in equals 2 times value of D times value of M1 divided by G. Okay, so it's right up here if you want to see what I did again. Right there. And all I did was exactly what this tells me to do. 2 times D times M1 divided by G. Okay, and then I'm going to enter. Hopefully that will be my slope. I don't know. And the times is just an asterisk. Okay, so shift 8. How are we doing? Are we okay? Are you ready to graph? Isabel's like, let's go. Let's do it. I stole it. I didn't make it up, but I didn't. It's not from my data. I'm so excited. I want to make a graph. Okay, ladies and gentlemen, I want you to take a look up here. I'm going to walk through the graphing process. You're going to go to Insert. If you're on a Mac or it's a different version of Excel, it'll be a little bit different, but it'll be the same process. Insert, and then you'll have a choice of types of graphs. You always want a scatter plot. You don't want the one that looks like a scatter plot that has like connected the dots. That is not a good choice. You want the plain old scatter plot. Can everybody find that? Insert.
You're slow.
So insert scatter, we're going to click on that. You want the one that doesn't have anything, and it's probably just going to look like a dot. That's like, great. Thanks so much for that. You're going to right click in the area, like in the graph, and say select data. Is everybody there? Okay. Let me show you again. So you've got this graph that is a huge bunch of mess. It doesn't matter. all I want you to do is to right-click in the graph area. No, don't put any lines in it. It should be the one that's just dots. Okay? And then you're going to say select data. Are you guys where I'm at?
Yes.
All right, ladies and gentlemen, let's go. We're all here. Can I stay with me for just a couple minutes? So if you have anything over here right now, remove it. If you didn't have anything there, don't worry about it. Okay? Go to add. And you want to change your x values. What did you want your x values to be? 1 over m, right? So did y'all see what I just did there? Okay, I need you to watch because I don't want to do this 500 times. So let me do it again. I'm back here, okay? I'm going to click add. Everybody click add. Is everybody here? Okay. See where it says series X values? Yes, everybody that's here sees that. I'm going to click on this little button on the side, and it makes it little. And then I'm just going to grab these 3 values. I'm just going to grab down like this. I'm just moving this over so you can see it. And I'm going to hit the little blue button. Okay. I'm going to do the same thing with the Y values, except I'm going to select the T squareds. Whoa, those are bad. Okay. And then click OK. I don't think they should matter. And then I'm going to click OK again. And then I'm hoping your graphs look better than mine. Because that's ugly. I think there's a problem maybe with that one. I'm going to go with that. Let me come take a look.
Yeah.
And those on the right, just based on what I'm seeing. Mostly because these have all the same value for M. There's something not right. Because these are all the same. Because that really yes. These three should be different. Yeah. Okay. So we're not quite there. We're getting close, but we're not quite there. Some of you have things that look pretty much like they're in a straight line, and maybe you have a bunch like this, and then you have one up here. If it looks like that, that's fine. That's fantastic. Because they're still in a straight line, you just took a little break in between, right? That's okay. If you have one that's like this, that would be an outlier. Do you agree? Whether it's there or wherever it is. Let me show you how to deal with that really quickly, because I'm thinking I have an outlier. I'm going to hope that it's this one. Okay? I'm going to show you how to deal with that in a honest, scientific way. Okay? So as a scientist, we're not just going to delete data. That's not okay. But I don't want to do analysis on this because I think that point is wrong. So what I'm going to do, I'm going to move this just a little bit so I can take a look at it and figure out which data point is the icky one. It's the one that has the smallest value for 1 over m squared. So I'm thinking that's this one here. Do you guys see what I'm saying? Because this is my m over m. 1 over m. That's my smallest value. So I want to get rid of that one. So this is what I'm going to do. I'm going to right click, say select data. We just did that last time, right? Add. I'm going to add another series, and I'm just going to use the data that is good. And when I do that, now, do you see that? Well, I guess you probably can't see this is a different color. But this one is a different color than these two. So these ones are the one I want to use. Now, I want you to right click on the data, the good data, on one of the data points of the good data on your graph. Let me say that again. Right click on one of the good data points of your data, and then click add trend line. Okay. I'll come over there and just help you in just a second. What kind of trend line do you want? Linear, and you can't quite see this because my projector is awesome. But if you go down, you should see a thing that says display equation on chart. And I'll help you find that if you don't see it yet. Okay. And that will give you the equation with the slope and the y-intercept that your data has. Nope, it's supposed to be a line, right? We set it to y equals mx plus b. Yeah. How'd you do? Okay. This is what I want to do. I am going to are the place that you're and then you save it to some place.
All right.
Okay. I want to finish first. Yeah. Don't save it. Not save it. The places online, that's fine. It's not. Once you're done saving it, make sure that it's all the way shut down. It's a black.
No lights. No pretty lights.
And then
Make sure there are no pretty lights.
no pretty lights. Yes. Fine.
Oh, okay.
So click on the data type, right click, and then right click, and then say and then sure. There you go.
Can I get something?
That's kind of close.
Yeah.
Better imagine, right?
Although,
On the right track.
right? Actually, no. It's really weird. It's really far off.
That's fine. That's fine. You doing okay? Okay.
That's the outliers. That's the outliers.
You should mention it. Making you at the end of class, not during class. We'll just do it later. So you need it. Again, please make sure that your computers are all the way shut down before you close them. What's that? Okay. Yeah, that's fine. In just a moment, I'm going to put up some conceptual questions. Thinking about things moving. Getting our brains back into the things moving mode. So our brains have been sitting in this nice dark room for a little while. I want you to take a look at these questions. I'm going to let you look at them individually. So you might want to get a piece of paper out to write down some comments so that you don't forget. I'll let you look at them for a couple of minutes, maybe a minute individually, and then I'll let you discuss. And again, staying with your group. Make this just a little bit smaller so you can see the whole thing. Take a look at these 4 questions. Again, this is oops, sorry, I'm just going to move this so it's a little easier to see everything. There you go. Okay. Go ahead and talk.
Landing after jumping. Your acceleration is comes ground, but your velocity. Part is not necessarily for your acceleration. It's perfectly straight line, make it moving at constant velocity. Highways, the highway is straight, then they can, when they are both they are not so to have equal acceleration. And for a yes, you might have to get the killer and head back with the rest of yeah. Or they have to loop back from that to
You ready?
Yep.
Yeah? All right. We're going to start with the back corner group. One of the following statements is incorrect. Which one is it and why? A, why?
Velocity has
that make sense?
Yes.
You all agree? Awesome. Let's move up to this corner. Give an example from your own experience, which the velocity of an object is 0 for just an instant of time. The acceleration is not. What'd you guys say over there, Jordan or Mira or V? Go ahead. Okay, which way is it accelerating? Yeah. Acceleration to gravity is always pulling this way, right? Yeah. Anybody else have another example?
Landing from a jump. When you're hitting you're accelerated. You'd be accelerated back upwards by the normal force when you hit the ground. But you would not have a velocity from impact.
Sure. That makes sense. Does that make sense to you guys? Yeah, absolutely. Absolutely. Good, two good examples. Number 7. Let's go to this middle group here. What'd you guys say? At a given instant of time, a car and truck are traveling side by side in adjacent lanes of traffic. The car has a greater velocity than the truck. Does that necessarily mean the acceleration is greater?
No.
Why not? No is the right answer. Yes. So the car has a greater velocity than the truck. If the car isn't 0, that means it's right? There you go.
Or you can just have the straight height and neither of them change speed.
Number 8. Average velocity for a truck has a positive value. Is it possible that the instantaneous value or velocity at any point has a negative value? What'd you guys say over here?
We said it'd be possible.
Sure. Yeah. Yeah, so when we say average velocity, we're talking about the total displacement over the time, right? It's not time to go yet. Don't pack up. We've got another 4 minutes. Oh, my goodness. Okay? Come on. Give me an example of a trick where your velocity is positive. I'm not going to call on you because there's too many things there. Velocity is positive, but instantaneous velocity is not. Does that make sense? So at this point we're going this way, and at this point we're going this way, but over here we're going backwards. Even though overall we still made a positive displacement. Absolutely. Absolutely. Okay. I promised you a derivation, one more derivation, didn't I? Can we do it right now? Why not, right? What else are we doing? Nothing. All right. This one's super fast. Here it comes. Here we go. Acceleration is VF minus VI over T. Do you agree? Yeah, we agree with that. Solve that for T. If you have T all by itself, what is it equal?
Yeah. Also divided.
Is that okay? Okay. Now, the last time we were together, we did establish another equation that looks something like this. Displacement is 1/2 VF plus VI times T. Sound familiar with like the second one we did, I think? I'm going to take this really awesome nastiness and put it in for T. Does that sound okay? Mm-hmm. Why not? Let's do it. 1/2 VF plus VI times VF minus VI. That's interesting to us. All over N. Have you guys seen this kind of thing before?
Yeah.
This is the what? Anybody?
Difference of the square.
Squares? Difference of squares? Yeah. Yeah. Difference of squares. So we're going to multiply two values together. For now. We're going to say 1. Well, I'm not going to leave the 1. Put this all over 2a. Right? So we're going to 2 on a. Here. All right. So we're going to do that when you do the squares. What are we going to get? So v times v is v squared. V times v is just going to be the vf squared minus vi. Apparently it's time to go. All right, it is time to go. So but that is it right there.
Pick him in handy.